the state of the art. So if Formula One wishes to maintain a claim of being the pinnacle of technological advancement, the argument that Dr. Boretti makes here is the rules don't really say that's what we're opening the door to. We've been better than this already with what we now consider old technology engines. So the argument might be made that the way the new technology engines would advance the state of the art is not so much through the engine technology as through the kinetic energy recovery systems. So let's look at that argument. This kind of summarizes what I showed in the previous slides. Now, talk about the Formula One curves. This is really a strategic power boosting device, and absolutely not, under the Formula One rules, a fuel-saving device akin to what we would want in a road car. In road cars, up to 70% of the braking energy can be used through the kinetic energy recovery system to as a power boost in the re-acceleration of the car. In other words, we're slowing the car down, under braking, we are stealing that kinetic energy, we are recovering it into our KERS system, and as we re-accelerate the car back up, we immediately reuse that energy. We spool it back into the system to re-accelerate the car. That would be the objective in a streetcar system, and maybe 70% of that braking energy we might be able to do that. Where are the benefits? Fuel economy, because any energy in that reacceleration that we're getting from the recovered kinetic energy is not energy we have to be getting by burning a fossil fuel. So we benefit the fuel economy and effectively the power and torque through the streetcar's use of that kinetic energy recovery system. However, the Formula One KERS, under the rules, say that the motor generator unit generates it under deceleration motor to resupply it. That motor generator kinetic energy storage unit cannot exceed more than 2 millijoules in any one lap, and that the energy released cannot be more than 4 megajoules in any one lap. So we're limiting how much we can store to a percentage much less than the 70%, and we're applying it so that you can only reuse so much of it, and you can only really reuse it in a limited period, and we know darn well that period is going to be push to pass. That's when it's going to be reused. It's not going to be used to re-energize the car to spool it back after you come out of the slow corner. That's not what the rules allow you to benefit. So what this says is, this does not really yield a KERS device that supports levels of past performance, because we're not going to use it to elevate the cars above where they've been in the past. We already showed that in the previous charts. Nor are we going to get better fuel economy, because we're not applying that energy back into the system in a way that benefits fuel economy. During sharp decelerations, the braking is mostly friction. It's not going to be KERS braking. The KERS storage, when fully charged, the driver will use that KERS boost strategically when it's convenient to gain or defend positions. It's going to be a push to pass. Thus, only a very small percentage of the braking energy that is stored in the KERS is actually reusable, and the way we're going to reuse it does not really benefit a technology that's relevant to future streetcars. Here's a simulation that was done regarding a Formula One car, competitive lap times at the 2011 Monaco Grand Prix under acceleration and braking. He used this to come up with an estimation. Actually, I think it was Danny Knoll who used this in support of the paper to come up with an estimation of the propulsive power that the engine has available to supply or accelerate the car, and the braking power needed to decelerate the car, how much energy we have, and he's shown here a plot that shows that the propulsive energy the engine would have is 13 megajoules, the braking energy 0.9 megajoules. However, the KERS braking alone cannot brake the car to the deceleration exceeding 6 Gs, which is frequently necessary in Formula 1, so that's obviously going to have to be friction, that's not going to the curves. The long and the short of it is that there is a huge potential for the curves in all of the energy that we can get out of the car under braking, and the need to re-accelerate. The potential is there, and if properly developed, the curves might permit the cars, the Formula 1 cars, to achieve a dramatic fuel savings if in fact we were taking the braking power and using it to re-accelerate the car. That potential exists, but not under the rules. Because the way the rules are formulated, it is simply going to be a energy storage unit that you use as a push-to-pass. So the conclusions here that Alberto and Sohail had intended to present is that the potential exists to create a fuel-saving device in Formula 1 that stores the energy gained during deceleration and uses it on a subsequent, and that would be the next subsequent re-acceleration. However, the 2014 rules allow only for curves which provides limited strategic power, because we are only allowing it to store so much, and that power will be used for an improved passing potential. So the strategic curves as currently envisioned under the 2014 Formula 1 rules really has no relevance for road use. A curve storing energy for a very limited time and reconverting it for re-acceleration, conversely, has considerable application to road cars. But one technology is here and the other technology is here. The argument would then be that the reason this is being adopted in Formula 1 is more a politically advantageous reason to make Formula 1 appear more civically responsible, while not truly creating a situation where Formula 1 technology can add relevancy to eventual street technology. If the declared goal of the new rules is to go greener, then the best option would be to introduce a simple fuel consumption limit over the full race, and then allow the research and development people to work out the best possible devices to achieve this goal. That, on counter to where we are headed right now, would say, if we limit the fuel, and we have to conserve, then we're going to look at ways to make that car run better with less fuel. That's going to, aerodynamics will factor into that, rolling friction will factor into that, but so will energy recovery systems that are then relevant to societal needs, because it will take the energy, store it short term, and reuse as much as conceivable, as much as possible, to re-energize or re-accelerate the car, thus helping to meet those reduced fuel consumption limits. So that is really what Alberto believes would be the best rule scenario if we truly wanted to make Formula 1 of the current era both technology leading and relevant to the green movement. Whereas what we've really done is create one that is, by appearances, green, but does not really keep Formula 1 at the forefront of technological advancement and relevancy. Small height, I think I just basically said everything that's in there. So, again, I'm the third string quarterback, and I probably should have just turned this over to you and let you do it, but go ahead.
Okay. Well, I've prepared no slides, so I think that you should read completely the regulation to complete your view on that. Let's go to the first scope when we start with scope to think about Formula 1 for the future generation. What is important in technology transfer with racing? Obviously, the goal of the racing machine is not the goal of your road car. You have two different missions. and so you have different problems. To a certain extent, the racing vehicle is much simpler than the road car. And what was important to us was to push on the technologies that are relevant for road cars, not to the means, because when you go racing, your only scope is to be faster. Okay? So the first point is that one very important point of this regulation is there is a fuel flow limit. We don't speak about that. A fuel flow limit means that this is the fuel flow you have and do what you want with it. But if you have more horsepower and you will be faster, it's just because you have more efficiency. That is, you burn it better. And that's one point. So, instead of being just a horsepower race, it becomes an efficiency race on the combustion engine by itself. That is, if you have more horsepower, that is, you are more efficient. Okay? This is slightly changed because most of the engines today, when they have more horsepower, they have more fuel consumption. Then, let's look to some detail of the technologies. Direct injection, yes, almost known, 500 bars. This is not usual, and the technology do not exist today. And if you go and discuss with people in the research labs, they will all say to you that one of the main drawbacks of direct injection is the spray you obtain with 100 bar injectors that are now currently used. Some are working with 200 bars. Nobody has reached 500 bars. We know this is a trend that the motor industry will go, so to develop it in Formula 1 before makes sense. Then the turbocharger. Yes, turbocharger, that's true. In the 70s, if you were going to Detroit or to any car manufacturer and say, well, you know, in 30 years' time, more than half of the production cars will have a turbocharger, which is the case today. Everybody will have low for now. Okay, maybe some sports application, okay. Now, this is a reality. So what have we done? You can recover exhaust gas energy from this turbocharger because you will have two electric machines. You'll see in my presentation this afternoon. And this electric machine on the turbocharger is very important because you envisage a completely different way of using the turbocharger. You use the turbine, pushed by the exhaust gas, to recover energy, and at the end, the balance of energy is completely different, because you will have some points where you penalize the combustion engine and maybe lose 5 kilowatts to recover maybe 30 kilowatts, and then you can put it down. Obviously, this is, in racing, only with the scope to have more horsepower, but in an efficient way, because the fuel consumption is limited. So, I really believe that when we built this with engine engineers around the table, we just thought about what are the technologies that will be pushed in the motor industry in the 10 years to come, and how to apply them in racing, but in a completely different world. Because when you use a car in racing, you are completely just focused on pure performance. And that's why we built this regulation. I think another point that is clear is the weakness of the batteries. We spoke this morning about electric vehicles, but what is the main problem with electric vehicles? Remains the battery or the energy store. And for that, the Formula 1 regulations state a minimum and maximum weight, so a very limited weight of batteries, to push you about the efficiency of the batteries. Because what limit today on road car the electric use is really the range. We were speaking about smartphones and electric cars. There is a main difference. it's already a few years that we learn that we will have tomorrow electric cars, or today we should have electric cars. But this is not exactly the reality, because you have not a battery to match. Because when you take a petrol car, well, you have an autonomy. You can decide when you go and how far you will go. When you have an electric car, you need to be cautious. And this, the difference with the smartphone is that if 10 years ago someone would have told you, you will have a smartphone to do this, this and that, you would just think it's stupid. But what happened is that the technology was forward. That is, first they built this and said, try it. But it exists, the product exists. And everybody understood that with that, you have much more facility to do a lot of work. So you use it. While with the electric car, we are just saying, you will have this one and it will do this and that. The reality is that you cannot have it. You cannot go to the next shop and have an electric car because the batteries are not developed enough or are not at the level that with a reasonable amount of weight you can have enough autonomy or range. So that's why also in Formula One we pushed to have a very small battery to push the development on that. So at the end, the main point with this Formula One regulation was to underline what are the technologies where there's some, locking. And this is where Formula One engineers have to work. And I think this maps the goal.
Okay, so no, Gilles, I think what you're saying is that Alberto in his analysis missed 2 or 3 key parts of the 2014 regulations when he did his analysis. The fuel flow and the objective in pushing certain aspects of future technology. And I know, having worked with US Car for many, many years, the USABC, the United States Advanced Battery Consortium, has been spending millions of dollars per year pushing battery technology for the past 10, 12 years. And A123 is one of the people that they've been working with, and people like that. So, Dennis, you had a question?
In fact, I was going to notice that in Boretti's paper, he mentioned nothing but this energy recovery system, the broader sense of what F1 is looking at for 14, with turbo compounding, which of course will be discussed this afternoon. So there's yet another way to get energy from that engine in a way that has nothing to do with pairs. That's why we want to call it a more general energy recovery system.
Yeah.
But it has to do with energy recovery from the heat of the turbo, which of course is that new technology. It's new from the point of view of performance engineering. It's long used in the trucking industry, but it's used now for performance, and thus I think it's very, very relevant. So in a way, the presentation making light of the 214 regulations have omitted, as you say, some important aspects they have.
Alberto's not here to defend himself.
No.
I just want to point this out. I will not comment on it. It's not a polemic or whatever.
No.
Just to complete the presentation. I think, when in FIA we had once a former research minister and brilliant scientific person that come to us and say, we need to do electric Formula One. Okay, this is the future, electric Formula One. Okay, you may have some problem with Mr. Eccleston about Formula One, but that's another story. I don't care. And so we made a few assumptions with the best possible batteries you can find. I mean, not speaking about batteries that are widely used, maybe some very specific military use of batteries. Okay? And we came back and say, well, to have the kind of performance you have on the Formula One, that is a power-to-weight ratio that is fitting and so on, and a certain lap time on the track. the maximum autonomy or range you can have is 1 lap, maybe 1.5 lap. Then if you want to have a 200 kilowatts car with maybe 800, 900 kilos, with like 350 kilos of batteries, you may be able to run 30 minutes. I said, no, this is not the scope, you are not ambitious. But it's not a matter of ambition, it's just that today's battery technology do not allow you, even using the best technology, to have enough range. That's a fact. So we first have to push the technological development before we can use it.
I would like, since it's 1:15, would you to get starting again at 1 o'clock, because I know that a lot of us here are going to be back